Okay, this is my second screencast on Lewis structures. And the big thing that I want you to do with these is to make sure that you pause and try these first. So the first thing I'd like you to try is to do these three elements: fluorine, oxygen, and nitrogen. So that's F2, O2, and N2. Pause and start with fluorine first. All right, fluorine has 14 valence electrons. That's 2 times 7 valence electrons. So our first step is to draw the skeleton structure. That's the atoms connected by a single bond, and then fill in any empty sides on the atoms with pairs of electrons. Then we need to check to make sure that we have 14 valence electrons: 2, 4, 6, 8, 10, 12, 14. So that checks. And then lastly, we need to check for octets around all the atoms. So there's 8 around that fluorine, and there's 8 around that fluorine. Pause it if you need to and count all those up too, so you can verify that those are 8. All right, oxygen has 12 valence electrons in it. So again, oxygen connected by single bonds, put in pairs of electrons around all the atoms, and now we count up the electrons. And if you take a look at the fluorine, you'll have a guess that we're not going to get the right answer. 2, 4, 6, 8, 10, 12, 14. So this is too many electrons. So what we're going to have to do is erase a pair of electrons, and now we've got 2, 4, 6, 8, 10, 12. So yay, we've got 12 electrons, but we have to do the octet check. There is an octet here, but there isn't an octet here. There's only 6 electrons, 2, 4, 6. So we're going to have to do something to make sure that both these oxygen atoms have an octet. And the way to do that is to move the valence electrons into an extra bond. So I'm going to draw this completely over to show you what I'm talking about. Oxygen, oxygen, double bond. And I'm going to shift these just for symmetry's sake, just to make it look pretty. Put those on opposite sides like that. And I've got those two over here. And now this adds up to 10 valence electrons, 2, 4, 6, 8, 10, but nobody has an octet. But this pair of electrons here that I moved over here, I'm going to draw that. So this is a double bond. And it means that there are 2 pairs of electrons, so in other words, 4 electrons there. So we have 2, 4, 6, 8, 10, 12 electrons, so now we've got 12. And then if we check for octets, there are 8 valence electrons around this, 2, 4, 6, 8, and there are 8 here, 2, 4, 6, 8. So there we go, this one checks out. Okay, so hopefully you paused before this. Let's take a look. Nitrogen has 10 valence electrons. If you haven't paused yet, stop and try to do this. Okay, nitrogen, we're going to do the same thing. Single bonds. And by now we already know that this is 14 valence electrons, so this is going to be wrong. And since there's 14 and we need 10, that means I'm going to have to get rid of 4 valence electrons. I've got 4 too many. So it doesn't really matter where I do it. I'm going to, let's say, erase those 2 and those 2. So now there's 10 valence electrons, 2, 4, 6, 8, 10. But neither of these atoms has an octet. Both of these only has 6 valence electrons around it. So that means I'm going to have to do what I was doing before and move electrons to make a multiple bond. So let's see what that's going to look like. Got nitrogen and a double bond and a pair of electrons, pair of electrons. This one has moved into this bond, so there's now only going to be 2 over here. So this adds up to 10 electrons still, 2, 4, 6, 8, 10. But this nitrogen has 8 electrons, 2, 4, 6, 8. This one only has 6, 2, 4, 6. So this still doesn't work. We're going to have to move 2 more electrons into a bond. And it can't be this one because that would still leave it with 6. We're going to have to move this one into a triple bond. And triple bonds are possible. So nitrogen, triple bond, nitrogen. It doesn't really matter where you put these pairs of electrons. I try to make my Lewis structures look symmetrical just because of aesthetics. But anyway, we still have 10 electrons. 2, 4, 6, 8, 10. And now everybody has an octet. There's 8 electrons, and there's 8 electrons. Stop and count it to make sure that that's right. Okay, so get ready to pause again. Your next task is, well, let me review real quickly. So fluorine had a single bond between it because it had 14 total valence electrons. Oxygen had a double bond because it had 12 valence electrons, which means that it had to shift some over so that there would be 8 between them. Nitrogen only has 10 valence electrons, so it needed a triple bond. All right, next up, try carbon dioxide out, pause the video, and work on carbon dioxide. All right, so first off, we need to do our valence electron count. We've got 4 carbon valence electrons and 2 times 6 valence electrons because of that 2. That gives us 12 valence electrons plus 4, 16 valence electrons. What's going to be the center? Well, the carbon is going to be the center. Usually, unless we're talking about hydrogen, which is always on the outside, usually the first atom is going to be in the center of these molecules. Also, the fact that there's 2 oxygens suggests that it's going to be on the outside. So we're going to draw carbon in the middle, single bonds, and electron pairs on the oxygen. Let's do our count. Oh, I almost forgot to put electron pairs on the carbon. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is 20 valence electrons. That doesn't work. Pause and count the electrons yourself to verify that for me. All right, so let's erase 4 electrons. So now there's 18, and now there's 16. Okay, so now we've got 16 valence electrons, but the carbon only has 4 valence electrons around it. The oxygens have 8, but the carbon only has 4. So we need to redraw this and try to shift things around. So if we were to take a pair of electrons and move it into a double bond, we can see what that would do. Let's try that on both sides. Well, let's try it on one side first. Oxygen. All right, now that we've added the 1 double bond, the oxygens have octets, but the carbon still doesn't. It's only got 6. So we need to try for a second double bond. Okay, now with a double bond between the carbon and both oxygens, we get 2, 4, 6, 8 electrons still around the oxygen and 2, 4, 6, 8 around the carbon. So there's an octet, and there's an octet, and also there's an octet. So this is the correct Lewis structure for carbon dioxide. Okay, last one. This is called nitrosyl chloride. This is an interesting one because we're seeing we have 3 elements in here, but think of it as like NO2 or NCl2. Just nitrogen's going to be in the center, and we're going to have oxygen and chlorine connected to it. So try that one out. Okay, well, remember how with carbon dioxide we had 16 valence electrons and we needed 2 double bonds between the 3 atoms? Well, with this one, we're going to need to have only 1 double bond. Let's see how that works. Okay, we've got, this ends up being the 20 valence electrons, as we saw before, with the single bonded oxygens to carbon, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So what we're going to need to do is to get rid of 2 electrons. I'm going to get rid of 2 here on the nitrogen and shift 2 electrons into a double bond. So when we do that, we get chlorine, single bonded, nitrogen, double bond, oxygen, oxygen. Don't worry so much about why I put the double bond on oxygen instead of on the chlorine, except remember that the halogens tend to make 1 bond and the oxygen family tends to make 2 bonds. So this way we get oxygen's preferred number of bonds and everybody gets an octet. So 8 electrons, 8 electrons, and 8 electrons. And that should add up to 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. All right. If you didn't get that, pause it, double check all my math, and try it out. I hope this was helpful, and please make sure to keep on practicing.